Use implicit differentiation to find dy dx in terms of x and y. So we've got 3x squared plus 3 equals ln of 5xy squared. All right, so let me rewrite it. 3x squared plus 3 equals, leave some space, ln of 5xy squared. All right. When we take the derivative with respect to x, the left side, easy peasy lemon squeezy. Okay? So the derivative of 3x squared, 6x. The derivative of 3, nothing. The right side is going to be chain rule and something else. So chain rule says you have outside stuff. Take the derivative of it. So the derivative of ln of blah is 1 over blah. Okay, keep the inside stuff as is, like so, but then multiply everything by the derivative of the inside stuff. That's going to require product rule. So let's go off to the side and find out what the derivative of the inside stuff is. We have the inside stuff is 5xy squared. I will call u and I will call u v. Okay, so the derivative would be u prime v plus v prime u. So I know what u is. U prime is the derivative with respect to x of 5x, which is 5. And v prime is going to be the derivative with respect to x of y squared, which is 2y dy dx. Now, when you take the derivative of a y with respect to x, you have to attach dy dx. So what now? Well, we have u prime v is going to be 5 times y squared plus v prime, which is 2y dy dx u, which is 5x. Okay, so we're going to multiply this guy to 5y squared plus 2y, and let's move this 5x over and make it dy dx. Let's just clean it up that way. And I probably could have multiplied 2 and 5 and made it 10, huh? Probably could have, probably should have, and I probably will in the next step. What I'm going to do first is I'm going to multiply both sides, though, by 5xy squared to get rid of u. Multiply both sides to 5xy squared. So that'll give me 30x squared y squared equals, nothing changes with the purple except I'm going to clean these guys up. So that's going to be 5y squared plus 10xy dy dx. Let's subtract 5y squared from both sides. Subtract 5y squared from both sides. So 30x squared y squared minus 5y squared is going to equal 10xy dy dx. Last step, divide everything by 10xy, everything by 10xy, and some simplifying happens, right? And we'll write it over here. 30, 5, and 10 are all divisible by 5, so 6, negative invisible 1, and 2. They each have an x. No, they don't, but they each, so the x's, there's no x in common, so x squared, x. But they each have a y in common, so y squared becomes y squared becomes y, and y is now gone. And so that leaves us with dy dx equals 6x squared y minus y over 2x. Implicit differentiation, kind of painful, lots of fun. Like a tattoo or a nose piercing. Like and subscribe.